All right, welcome to The Explainer. Today, we are diving into a new kind of global race. It's happening right now with billions of dollars and, frankly, national pride on the line. But this isn't about planting a flag on the moon or Mars. This is something else entirely.
So, what is this new global competition? What's the thing that has countries all over the world mobilizing their sharpest minds in their deepest pockets?
The prize? Well, it's something called quantum advantage. That's the tipping point. The moment a quantum computer can solve a problem that no classical computer on Earth could possibly crack in a reasonable amount of time. And you better believe that being the first to get there is a massive strategic goal.
Now, we've got to be clear about something. A quantum computer isn't just a souped-up version of the laptop you're using. Think of it like this. Your computer sees the world in black and white, just ones and zeros. A quantum computer sees an infinite spectrum of colors, all at the same time. This lets it tackle problems with the kind of complexity we could barely even imagine before, problems we once thought were literally impossible to solve. But here's the twist. This isn't one simple sprint to a single finish line. It's way more like a global game of chess, a really complicated one, with dozens of countries all making very different, very strategic moves.
To really get a handle on this landscape, we can basically group all these national strategies into a few key types. You've got your builders, your orchestrators, and your niche strategists. And each one has a totally different idea about how to win this thing. Let's dig into how they all stack up.
Okay, so these strategies basically fall into three buckets. First, you have the builders. Think Australia, think China. They're making huge, centralized bets to build the actual hardware from the ground up. Then, there are the orchestrators, like the UK. They're focused on growing this really rich, complex ecosystem of startups, research, and partnerships. And finally, you see the niche strategists, countries like Finland, who aren't trying to boil the ocean. Instead, they're using their specific national strengths to get a focused, tactical edge.
Let's start with those builders. And this number just says it all, right? Australia, working with a company called PsiQuantum, is pumping almost $1 billion Australian dollars into one single massive project down in Brisbane.
And their goal is, well, it's incredibly ambitious. They are swinging for the fences, trying to build the world's first utility-scale, fault-tolerant quantum computer. Utility-scale means it's powerful enough to solve actual commercial problems. Fault-tolerant means it's stable enough to run without constantly making errors. Those are two of the biggest hurdles in quantum right now. And to get there, they're aiming for a 1 million qubit machine by 2028. That is a gigantic leap that would just skyrocket Australia to the top of the quantum world.
Okay, now let's pivot to the orchestrators and see how different their approach is. The Netherlands is a fantastic example. Their strategy isn't one huge bet. It's more like engineering leadership, but across an entire ecosystem. They've invested over 600 million euros in their Quantum Delta initiative, which is a full-stack approach that links everything together, from materials science and chip making all the way up to software and the people who will actually use it.
The UK is another classic orchestrator, and they are playing what the sources are calling a long game. They have a £2.5 billion 10-year strategy. Part of that is building a national center that will host 12 different kinds of quantum computers so researchers can test them out and see what really works. They're connecting world-class universities with a buzzing startup scene. See, their goal isn't just to build one machine, it's to master the whole quantum environment.
And that brings us to our last group, the niche strategists. Finland is the perfect poster child for this precision play. They know they can't outspend the giants. So instead, they're being incredibly smart and incredibly focused with their money. And the payoff for that precision is amazing. While some countries are talking about massive machines in the future, Finland went ahead and built a 50-qubit machine that's already online and available for researchers across Europe to use today. This isn't just a science fair project. It's a real, stable tool doing real work. It's just proof that a smart, focused play can have a huge, immediate impact. So we have all these different strategies, right? The builders, the orchestrators, the specialists. But no matter which playbook a country is using, this whole race has a great equalizer. A set of universal challenges that every single nation, no exceptions, has to figure out how to beat.
And there are two giants in particular that are standing in the way of quantum progress for everyone, from the biggest players right down to the smallest.
The first giant is the talent gap.
Simply put, there are not enough skilled people in the world to power this revolution. We're talking about everyone from the hardware specialists who physically build these things to the software engineers and algorithm researchers who actually make them do something useful.
And look, this isn't some small problem. It's a fundamental brake on progress. Even Australia, with its massive, nearly billion-dollar bet, admits right in its own strategy documents that the talent pool is, and I'm quoting here, too thin for the scale being targeted. This creates a fierce global competition for experts and a brain drain where smaller countries lose their top talent to the bigger hubs.
The second giant is just the sheer difficulty of the engineering. I mean, it's one thing to get a breakthrough in a perfectly controlled university lab. It is a whole other thing to turn that incredibly delicate quantum physics into a reliable, scalable product that you can actually sell. That journey from theory to a real-world product is long, it's expensive, and it is brutally difficult.
So, with all this money being spent and all these massive challenges, why does this race matter so much? I mean, what are the actual stakes for you and me?
Well, the stakes are enormous, and they really cut both ways. You've got this future with a profound threat on one side and an incredible promise on the other. The threat? A powerful quantum computer could, in theory, break the encryption that protects our entire digital lives, from your bank account to national security secrets. The promise? That same power could help us discover new drugs, design revolutionary new materials, and finally model our climate with pinpoint accuracy.
And that threat is not some far-off sci-fi plot. This timeline shows you just how urgent the race to defend against it is. Governments are already rolling out something called post-quantum cryptography, or PQC. The US finalized its new standards back in August 2024. The UAE is already making it mandatory, and the UK has set a hard 2035 deadline for the entire country to switch over. The race to build a quantum computer is also a frantic race to secure our data from one.
But that promise is just as powerful. National strategies are pouring hundreds of millions into solving some of humanity's biggest challenges. The UK, for instance, is funding projects that will use quantum for things like detecting dementia earlier and discovering brand new drugs. These aren't just abstract ideas. They could represent a whole new golden age of scientific discovery, all powered by quantum.
So we've looked at the players, the different strategies, the huge challenges, and the incredible stakes. But all of this, it really funnels down to one final critical question. Because this race isn't a zero-sum game. The source material makes it really clear that the future here will be built on this complex, sometimes messy web of collaboration and competition. You see countries forming alliances, like the UK and Canada have, while at the same time, they're fiercely competing against each other for talent and for investment. It's a new kind of technological diplomacy.
And that brings us to the final thought for this explainer. As this incredibly powerful technology starts to come online, and as all these nations build and partner and compete to control it, the real race might not be about who builds the first machine. The real question is this: who is going to write the rules? The ethical rules, the security rules, the rules of access for our shared quantum future? That's what we'll be watching.